So your CES software allows you to input costs for all these different parameters and number values for all these different parameters, most importantly. And the database has approximate value ranges for each of these through extensive analysis based on practice. And then in addition, you can enter some of these parameters by a dialog box. Right? That box looks like this FX term over here as a button. When you go to any particular uh, process, and then you can vary these parameters based in this range that's provided. And so if you click on that button, you can basically enter these values and then accordingly generate graphs of this manner depending upon the actual value that you generated in terms of relative cost versus batch size for a specific process. And that is how we ended up generating that information for those three different processes. Here's another kind of an example. We saw in the previous case when you have tooling, so sand casting, die casting, and low pressure casting, you could have that variation where the more the parts that you make, the lower the costs over the long run. However, there are production methods such as additive manufacturing. One specific example is electron beam melting, where you go directly from a CAD file, raster an electron beam through slices of these parts, and you build them off from a powder bed. In that case, you don't have a tooling cost because these are die-less fabrications of the same parts. So in those cases, typically you will have this relative cost index to be relatively invariant over production's batch size. There are some limitations to that type of an assumption because you're not necessarily producing one part at a time. You can, with a larger footprint, be able to make multiple parts. But largely this tendency, relative tendency, where when you have a die, you would have decreasing costs over larger production ranges, finally limiting over to material and labor costs at the high end of batch size is routine. Whereas for processes such as additive manufacturing, metal additive manufacturing in particular, in this particular example, you have a more batch size invariant trend in terms of part costs. Within the EduPack database, you can look at bar charts like we have seen for in the case of material selection for various properties. And mainly you can get to the point where you can cross compare overall costs for a number of different parameters for this a number of different process variables for a fixed set of parameters over here. You can generate plots like that depending upon the specific input that you might have, and you can decide to screen out some options depending on when you can make things. And you can see, at least for right now, additive manufacturing based processes tend to be more expensive than some of the volume manufacturing processes. So what does that mean? That it's not cost competitive to go with metal additive manufacturing? The answer is perhaps, and it just depends on this number over here. Okay, and it depends on the specific design. If a geometry cannot, or a material to build that geometry from is not available from many of these other competitive processes, then depending upon the value on the function of that component and would this be a more competitive process at that time. Those are the design considerations that go into additive manufacturing. We'll look at that separately in another course. And that is one of the preoccupations of my overall area of research here at AMIST, Additive Manufacturing Institute of Science and Technology. So the overall implications are we have to minimize cost, but to be able to do that, we also have to maximize value. Right? And There are modeling options available in EduPack at several levels, and then you can begin to use that as a filter to be able to rank options. And they use realistic generic inputs and provide an analysis to be able to then contact suppliers or contractors to be able to compare estimates with what is bidded out by different vendors. Those considerations basically go behind this matrix that we have seen earlier, where you have the rows involving processes and this x-axis over here in terms of economic batch size units, reinforcing the theme that there are certain processes that work better for small batches, and there are certain processes that work better for large batches, and have the unique capability to deliver on that. And so, recognizing the fact that how much things cost might be affected by not only the process that is selected, but the intrinsic ability of the process to deliver within that particular expected production lot needs to be taken into account into the overall considerations of cost model.